first of all, we develop our project with wood and make a prototype of it, and then we see that the prototype that we make is not so strong, so we choose to make our project with a metal plate. Then we take an aluminum rod and then cut it into two pieces, and then we make a file in both of them to make a half lap joint, and then we take a sheet metal and make a slot in it, and we also take a iron rod and weld a nut on it and adjust in such a way that this can move in this direction. Means the slot is so adjusted that can move freely in the slot, and then we make a milling in both of the slot to attach our ribbon in both of them, and then we make a drill in both of them and then pivot all the joints in them.
Basically, this step counter contains 2 aluminium rods and 1 iron rod. This is the upper rod which is fixed on the thigh above knee, and this is the lower rod which is fixed on the calf below knee. And when we walk, this angle will decrease and this will move towards this point, toward this rod, and as the angle between these two rods decreases, this will strike this switch and it increases the count on the calculator. And this iron rod also contains one joint, one nut which is fixed on the aluminium rod, and this can be adjusted while we are doing different processes. While cycling, angle between iron rod and aluminium rod can be adjusted by tightening this screw, so that the angle between this aluminium rod and this switch will be approximately 90 degree, and the switch can be triggered at 90 degree while cycling. If force exceeds, the spring will be compressed and the device will not break.
So our first idea for the step counter was a wooden product which we would have fixed on the front side of our knee. So basically we would have joined the two rods, one on the upper side of the knee and other on the lower side of the knee.
As shown here, the switch would be triggered when the leg becomes straight.
The problem in this idea was the switch would have been broken if the force would have been too much. So we rejected that idea and we switched to the idea that we fixed our device on the side of our knee. So that was the simple counter that we will fix on the side of our leg. Later on we found that we can improve our utility to a great extent by a simple spring nut mechanism. So we introduced this mechanism by which here our micro switch is here, and by this spring mechanism we can adjust the angle between this micro switch and the upper rod. So it will basically adjust our angle so that the lower rod could trigger the button at the desired angle. So in this we had two different mechanisms. One is that you see an engineering compass in which there is a bolt that is fixed on the upper side, which when you unscrew, it will widen the angle between the arcs of the compass. It was a bit difficult, so we rejected that and we switched to this mechanism. So as you can see, our nut here is a little curved. It was a challenge for us because the threading on a curved nut is difficult. So we hammered the nut after a certain gap so that the threading won't be destroyed fully, and we can fix the bolt so that our mechanism could be held at this angle. For our counter circuit, as you can see, this is our micro switch. We have fixed two wires to it, and these wires go inside the calculator. These two wires are fixed to our equal button, which when we trigger the micro switch, the equal button will be pressed and the count will go on by 2. So due to the small size of the IC, we had to fix the wires very precisely.
The major use of the device is we can use it for measuring the distance we have traveled during our walk. For example, you need to travel 10-meter distance, and the average distance of one step is suppose 1 meter. So accordingly, you need to take 10 steps, so that 1 meter into 10 step is equal to 10 meter. So in this way, our device can be used to counting for measuring the distance you have traveled. And the other uses are counting the number of stairs you have climbed, and number of pedals you have cycled during your cycling. As future scope of this device, like we can integrate our step counter with your smartphone, so that our smartphone keeps the daily track that how much distance you have traveled, how much steps you have taken, how much calories you have burned, and finally it will be useful for maintaining all your health data. Accordingly, it will be used for in your day-to-day life. Moreover, we can also make it wireless, as we have used wires in this device to connect the two platforms, and we can use Bluetooth to make it wireless, and many more devices which we may see in future. And the other future scope is we can make our step counter lightweight by using different types of material, so that it will be very handy and useful during walks.
As you can see, the step counter is fixed on the leg. The angle between the iron rod and the upper rod is approximately 90 degree. As you can see, the count goes on by 1.